Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Camera Tuesday, we're gonna talk about Zoom H series essential update. So let's dive deep into it. So basically what Zoom did is take this puppy, upgraded it and released a whole series of it. So H6 got an update, H4 got an update, H1 got an update. So this is a new lineup, and the core selling point of this is low cost. Let this be very clear. Again, if you were like, dude, this is $300, this is like $200, and this is $100, low cost in comparison to their own lineup, so to say, and even to other things. Yeah, that is like genuinely low cost. So low cost, portable, small audio recorders, meaning you have this, that's it, that it will work. It will record all the audio itself. It's not just a interface where it can, just like you need a PC. This can work on their own. It's a portable recorder, battery powered, and big ones can provide phantom powers based on battery itself. And you can have a lot of microphones, meaning you in H4 you can have 4 microphones and H6 6. So you can go YOLO on it. So that's the point. Portable audio recorder. They're quite handy, quite desirable for a lot of people, especially wedding photographers, videographers, and documentary and things of that nature, low cost news gathering, things of that nature. These are quite desirable tools. So low cost, so they are not the latest and greatest, but they are made more for, we're gonna give you a tool that gets you off the ground, so to say. Now what have been updated? Well, like this is very ancient. This went from micro B to USB-C, thankfully, and it has large SD card, which I genuinely was very angry when I bought this, because Zoom H1N is not a very ancient device, even though it has micro SD HC only. What the hell? This was released when XC was a thing. Basically micro SD HC, high capacity card, can only come to 32 gigabytes. XC goes to 2 terabytes. And when this was launched, 128 gigabyte, 512 gigabytes, those were available. So I have no idea why the heck this is so limiting. I have cards. I have SD cards that are bigger than that, but I can't put it there. So that was frustrating. Thankfully, this time they have upped the capacity. You can go to 12 gigabytes on most of them. So that's good. Now, the biggest update, where it's like, okay, that's a night and day difference, is 32-bit audio pipeline. I'll explain this puppy very clearly because I'm genuinely frustrated and angry how thoroughly messed up so many people are doing, and these are audio people, so I'm gonna go into the science of it. Then you have all displays has been replaced, so instead of looking like a ancient Casio display, it has a recent Casio display. OLED displays are there, not color. The cheap one only gets a black and white, but high contrast, easy to read. And then you have a very low grades display. Now launch price is rather same, meaning $99. You may think like, okay, can't I get this for like $70 or something? Here's the deal. When this was launched, it was again $99. So given the inflation, given all that jazz, it's kind of impressive that they have launched it at the same price, like especially with this one. And that's why this is like, you know, top seller in B&H. It's like $200. And the Zoom H4 was genuinely successful recorder, meaning it was selling like hotcakes. They had it refreshed 3 times. That's how successful it was. So it's very good. Unfortunately, if you are invested in H6 series of lineups where they had capsule modules, yeah, they yeeted the modules, meaning all these modules, if you have bought them, yeah, they will not work. The contacts have been redesigned. I have no idea why. There is no logical reason to do so. It's only just like creating e-waste and for planned obsolescence. Other than that, there is no logical reason for that. So it does hurt because again, audio equipments are one of those equipments that last for decades. So it's just 1 decade, lol. So this is Zoom's new offering. Now let's dive deep into 32-bit pipeline. Let this be very clear. I'm gonna do my best to explain this messy subject. Well, here's the math on paper. So if somebody's like, oh, 24-bit is enough. Mathematically, on paper, absolutely true, shut up, take money. But here's the math on paper versus real life is not the goddamn same thing. They are not same, because here's the deal, everything has limitations in dynamic range. For example, what about dynamic range of the word that you are capturing? It's bonkersly high. It can go very low. It can go rocket launch level loud. So you have a lot of range, like almost infinite range. Okay, now you enter your first choke point, that is your microphone, the physical capsules. It does not matter whether it's a capacitor that is changing capacitance to give you a signal. It does not matter it's a coil of wire moving in a magnet that is giving you the system. Optical system, if you have it, it does not matter. All of them have a physical range that they can represent. If it becomes too loud, it will physically break. That's why if you see people going pew pew, they have a different kind of microphone. Yeah, if you do normal pew pew on this, it will physically break the membrane. especially if it's too close to the pew pew. So you see, but there is a physical limitation of the microphones. You cannot have a microphone that can capture the smallest sound to loudest rocket launch. You have to find a right tool for the right job. But they generally have a huge range. That's the first choke point you have. Now, after that, now you get the data. So far, our choke point was never the microphone. It was always the stuff happened after the microphone. That's why you have the gain. That's why you have a gain, because we had to move the window of our quality sound capture to capture the best signal we can based on the environment. Because again, the window that we have in terms of recording is this small, the microphone window is this big, so we had a choke point. That's why the gain allows you to move that window either here or here. That's all you are doing. When you are adjusting gain, you are moving the window to here or here. That's all you are doing. So you got the mic signal, does not matter, capacitance, magnetic field, whatever have you. It goes to preamps. Now you have to understand, all the microphones, they are very weak. They're converting physical audio waves to electrical impulses of one type or the another. Fundamentally very small. It needs to get boosted in order to analog to digital converter to do its job. So preamps. Now preamps have some noise. Of course, its law of physics is very clear. It's like if you are boosting a signal, you're gonna introduce random noise to it, unless you are dealing it in absolute zero temperature. And that's why like a scientific instrument requires so much cooling. You do not have that. Again, room temperature, yeah, and hot temperature, yeah, it's gonna have a lot of noise floor. So you preamp it. Now that time you lost some amount of the signal. Then it goes to the analog to digital converter. Now on paper, this is supposed to be the magical issue, where it's like you just take the analog signal, chop it up, properly digitize it, and voila. Now be mindful, once you have a digital signal, problem is sorted. Meaning after that you can process it with Arduino, you can process it with ESP32, iPhone, Android, Apple, Windows PC, Linux PC, does not matter. Once you have digital signal, no problems. It's just going to that stage without messing up the feel of the sound, signature of the sound. That's the hard part. So preamp is the first limiting factor. Analog to digital converter is the second limiting factor. And all of them have some amount of noise. You cannot create a system which does not have this noise floor. So once we have this, so how do we solve this 32-bit? What does it do? What it does is, like, somebody came up with a very clever idea. What if we had two analog to digital converter? Because many people will say, oh, 24-bit has enough of it. If you open the chip manual, the ICs that are physically used in this, many of them have 32-bit IC, not float, linear 32-bit. So they have the range. Problem is, if you go very low in terms of basically very faint sound, you will not be able to gain it up in the software. And mathematically, you should be able to do, but all you will get is the noise floor. And what happens if the audio is reaching this point? It's not clipped yet, but it will start distorting in this zone. So people do not want a sound to be there. So there is a sweet spot where the audio conversion efficiency is like absolutely perfect, where you have what we call signal to noise ratio is perfect. So computers can properly discern it as like noise, signal. You want it to be very far apart, so there is no mess up. And that's why people generally want to make sure the audio is as high as possible. This zone is your sweet spot. But here's the deal. If you are here, you are very close to clipping, because microphone can go very far and real world has no limitation. So what somebody did is like, what if we put second A to D, meaning second preamp and second analog to digital converter. Now in terms of IC, all it simply means your microphone channel goes into two channels. Basically one channel input goes into two channel dicto, and one would be low gain, one would be high gain. So what you do, low gain one is basically, high gain one is your sensitive one. So very loud sound, very minute sound, it will directly boost it up to normal operation. So you get a very clean sound. Okay, that is there. Now what happens when you start to speak? It will clip. You see, it will clip the full scale. The digital is like, bro, I have clipped, I no longer have data, no problem. Second A to DC is like, I got you back. And it is aligned in such a way that you have this perfect switching to another perfect, so you can capture more than what microphone can do. So now you have dynamic range that exceed, let that be very clear, exceed what microphone can do. Now if you are having clipping in properly done system, that means microphone is messed up. Again, if you have like this sort of microphone and you put it next to pew pew, this will physically clip, so, or get destroyed. So now you get a full scale data output. Now be mindful, you will like, wait, doesn't that mean there is two audio channel? Yes, there is two audio channel. It requires mathematics to combine two of those audio channels. Without it, it's not gonna work. So that allows you to do that. Doing so, like once you have proper mathematical mixing, now you get what we call full dynamic range, meaning your microphone is now the choke point, not the digital to analog converter. You no longer need to set the gain, you no longer need to worry about preamps. If done correctly, the range of your equipment would be so wide that mics would be the limiting factor. not the system. So that is why when Zoom F6 was launched, it had no gain setup. It's like it was not necessary. So full system is there. And now you have that data that can be stored in 32-bit float without any limitation. And what you see here, right, like zero clipping, what is happening? It's about playback, because you have to understand, once you have the digital audio, you're not talking to an AI, you're talking to a human. So how do we human hear it? Do we have a USB plug on ears? No. So it goes again from a digital file to digital to analog converter, a DAC. Then it plays it back. So if anybody's like 24-bit is more than good enough, yeah, for an IMAX theater, not for normal places, because normal places, if the signal to noise ratio is not far apart, meaning the signal is not loud enough, it will be hard to hear. And if people complain about tenants being very hard to hear, that's the reason. It's not been mastered properly, because mastering is understanding that people's analog to digital converter, digital to analog converter is not magic. It's not like IMAX grade. So you have to tune it. So same tuning that goes into making sure the digital file is there, same goes during the playback also. So having 32-bit gives you enough room where you can just go YOLO on it. And that only makes sense if you have dual A to DC. This is the problematic part that for so many people are missing. And this delusional idea that your 24-bit is enough. It's like it's not enough if you have noise floor and you have extra headroom, and real world does not have limitation. So you want to be damn sure that your microphone doesn't, because be mindful, what is gain adjusting? Your window of capturing. So that fundamentally screams that, hey, your microphone has more range. It's like you put an awesome lens on a crappy camera. It's like, wouldn't you want to put an awesome camera capture device on an awesome lens? Same thing. That's why you have two A to DC. And be mindful, it's not limited to two. There is some Rode microphone that is like pro grade that has 4 A to DC. They have 4. Now, like, why do you need that? 2 gives you the biggest change. Going from single A to D to 2 A to D is like, whoa. 2 to 4 is not that whoa, but it allows you to have that sweet feeling. Because even in this zone, there would be a sweet spot where it's like crisp. The what they call quantum noise is minuscule, meaning the digitization is happening absolutely precisely. So you may need to stack 4 of them to get like full range, full sweet spot. So that's how the 32-bit pipeline works. So if somebody tells you 24-bit is enough, yeah, no, they're just mathematically within the laws of physics, they are wrong. That is why you have gain knob, and that is why if multiple digital to analog converter is used, you will no longer need the gain knob, because simply because your mic's range should not exceed it. Now, what if it exists? Again, that could happen if you have, let's say the preamps are designed for condenser microphones. They're assuming a certain voltage range, and you used a different sort of microphone. Then you could have some issue, but most of the time, generally it won't be there. So this is the 32-bit pipeline. So what about the products that Zoom has released? Though they have released 3. Now Zoom was the first company to release this 32-bit in the world. Now other companies have also captured up to it. So Zoom has refreshed basically all their old lineups with this technology. So no more gain knobs. That's why these things look so cheap, so to say. Because in the older one, they had a lot of knobs. Even this has knobs. So you had no knob requirement, because again, you have 2 A to DC perfectly matched properly, meaning your mic signal should be perfectly captured all the time. And the basic one gets a new high contrast black and white OLED display. So instead of 1990s Casio display, it has modern OLED display. So you get high contrasting one. Then you have H4E, which is the best selling one, which they have working their ass off to make sure that this also becomes a hit. This upgrades the feature set. Now it has 32-bit float for audio to PC, meaning if you have the right drivers in Windows, I do not think as of now when I'm recording this that Apple can do this, but in Windows you do have the ability that this can act as a 32-bit data port, meaning if you are doing a studio recording, let's say you have a drummer and they are capturing it, 32-bit does not require to be saved into this card and then you pull it out. No, it can directly save the 32-bit to your computer. Can computer software can do that? Yes, PC softwares are already there. Like they have been there for a few years. Before the hardware came out, the 32-bit was already there. So that's a sorted issue. But you do have to double check it, because again, many if you do not have proper drive pipeline, it may not work. So you do have to test it, but it can be done. Unfortunately, it does not have any functions on that, because everybody would love that if it's instead of sending 32-bit, it sends adjusted 24-bit, meaning 32-bit file is captured and then 24-bit is auto adjusting it. So you're streaming, let's say you're streaming, because YouTube is not going to eat 32-bit. And again, you do not even want to send 32-bit because the people's headphone will not work, because again, they have to keep changing the levels on the headphone. It won't be balanced properly. So it does have that 32-bit to your PC, so that could be a desirable thing. And there are some real-time audio editing options that you can do with some NLE, where you can just like, hey, I'm streaming, you have 32-bit coming in and it's auto adjusting to 24-bit, but it requires another software. I do not think OBS in itself can do that. Then you have H6E. Now this is this one, the biggest, most expensive one. The biggest change is now you get the swappable mic capsule, but unfortunately, because there's a new design, you have to buy the whole new setup. So for most people, either get into this or get into that. So these are the options that we have. Now, as of now, the biggest letdown of this is like they are still using the same preamps, quality of preamps and analog to digital converter. Like that is the biggest difference between cheap device like this from Zoom itself and expensive F series of lineup. H series is handheld, F series is field recorders. So field recorders, why they are so expensive? Even they have the same setup like this, the same 32-bit and all that, is simply because that field recorders have a bit more quality in their preamp. Because once the digital file is done, then it makes no difference. But to make that digital file, to digitize a file without self noise, that's the most expensive part. So doing that without self noise requires you to have expensive A to D, analog to digital converter, and very expensive preamp specifically. Like if you ever wondered like why the heck sound devices are so expensive, look into their PCB, the capacitors chosen. Everything is designed just so they can get best analog signal to preamp, then from preamp to recorder to converter as efficiently as possible. So quality wise, they look exactly like their old variant. Now, like, isn't that a good thing? Yes or no? Yes. When Zoom released H4, that was awesome. H1, I'm using it. It's awesome. But here's the deal. It's not awesome for 2024. It was awesome for 2010. Not now. So what are options? Let's say you want to buy it. What are your options? Well, because Essential series are using lower grade of basically analog to digital converter compared to Zoom's own F series of lineup, you may find it where it's like self noise is like, eh. Now let this be clear. If this is your first recorder, you will not know what's the damn difference is. But if you are coming from some other pro tools, you'll be like, eh. Or you want to go into that, you may not want to invest in it. So if you are like, hey, I want the best hardware possible for microphones, Zoom F3 may be a better choice. It may not fulfill all your needs, but this may be a better choice in terms of audio quality. Choice is yours. Now, be mindful. It's not a bad setup, but for 10 years later refresh is not that good. And the fact that they have changed the mic capsules, I'm like, and let this be clear. The reason why I'm saying mic capsule does not need to be changed, it is using same XLR. Think about it. It's like, oh, we had to do it for 32-bit. Then how the heck it's working with your XLRs? XLR did not upgrade from XLR to 32-bit XLR. That's the whole point. It's like same analog signal has to go. It will be cloned two places. One preamp would be low amp, one would be high amp. So it does not require any electrical change. It does not, like on the mic side, they just change it so they can create more e-waste and planned obsolescence. So for 10-year refresh, it's like a bit of a letdown. And this is the first time I have ever seen any pro level individual saying you may be able to go into Tascam rather than Zoom. This is the first time ever. Tascam was always like, bottom of the barrel, so to say. But now it's like, whoa, Tascam actually used a better, higher quality analog to digital converter and preamp. So I'm reasonably sure Zoom only did this so they can make sure that F series does not get cannibalized. So F series has better audio. You can look into Tascam Podo Capture. Be mindful, this is more expensive, but Podo Capture 6 is there. This is X8 and this is X6. X6 is cheaper. You may find it still fulfills all your need. For people who are looking into camera recording setup, you can use this. Now be mindful, because camera company never upgraded from 1998. They never had the idea of like, hey, what if we used 2000s technology and have USB audio input? We do not have that. So again, the audio captured is 32-bit. Digital file is awesome. You cannot transmit it digitally. You have to go through analog to digital converter again, then digital to analog converter again. Then, like again, it is going through way too many converters. That's why there is always far more self noise. If you take any Zoom, basically Rode Wireless Go 2, you take the 32-bit file directly from the recorder, compare it to your camera would be exponentially worse. Not exponentially as in like it's unusable. It's just like, it could be better, but it's won't be, because this is recording it, transmitting it digitally without any issue. After that digital, it goes to digital to analog converter, DAC. Then it goes through the cable into your camera. Camera takes it again, sends it through a preamp, again sends it through a basically analog to digital converter, then it stores it. So you have way two extra unnecessary conversions because there is no digital pipeline, which we had in mini disk. So that's why like 32-bit, if you really want to enjoy it, you have to go through post processing or use a smartphone for some reason, and action camera for some reason has the technology of USB audio pass through. So now you can use proper digital audio transfer. So these are the options that we have right now. So it's kind of good that we have 32-bit becoming more mainstream. I did not like the idea of like locking, hey, this cannot access a 32-bit recorder. I'm like, dude, these things can. So that's why like from Zoom's point of view, it feels more like, it's a bare minimum rather than like, oh, let me show you how it can be done. Because compare this monitor display compared to the Zoom offering, you're like, dude, Zoom never crossed 2010. This is 2020. So you have options. If you want to go 32-bit portable recorders, you have options. So this was my presentation on Zoom's H series of essential recorders that have been launched recently. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.